Welcome back, everyone. Today, what I want to talk to you about is another method for solving quadratic equations called completing the square. So here we have a quadratic equation, x squared minus 12x plus 11 equals 0. And the first thing that we want to do when we're completing the square is we want to isolate all of the x terms in the equation. So we simply just want to subtract 11 from both sides of the equation. And when we do so, we end up with x squared minus 12x equals negative 11. The second step for solving a quadratic equation by completing the square is to actually complete the square. And this is the tricky step of the process. So what we want to do is we want to take half of the coefficient on the x term. Now the coefficient on the x term is the b from our equation in standard form. So we want to take half of b and square it and add it to both sides of the equation. So in this case, we have x squared minus 12x, and we're going to take half of negative 12 and square it and add it to both sides of the equation. So we're going to take negative 6 squared and add it to both sides of the equation. And now to complete the process of completing the square, we're not going to simplify the left-hand side, but we're going to simplify the right-hand side. And we have negative 11 plus 36, which is 25. And then instead of simplifying the left-hand side by squaring negative 6 and having a trinomial, what we're going to do is notice that we have a squared term at the beginning of the trinomial and at the end of the trinomial, which means it's a perfect square trinomial, so we can factor it into a binomial squared. So we can factor it into x minus 6 squared. So now that we've completed the square, what we want to do is we want to take the square root of both sides of the equation. So I'm going to take the square root of the left-hand side and the right-hand side. And when I take the square root of the left-hand side, since it's a binomial squared, we end up with just the binomial, x minus 6. And then on the right-hand side, the square root property tells us that the square root of 25 is plus or minus 5. Once we take the square root of both sides of the equation, then we just have to solve and simplify to get our solutions. So in this case, since it's plus or minus 5, we have to split the equation into two equations and solve each one. For the first equation, we have x minus 6 equals positive 5. And the second equation, we have x minus 6 equals negative 5. And if we solve each one of them, if we add 6 to both sides, we end up with x equals 11 on the left-hand side, and we end up with x equals 1 on the right-hand side. So our two solutions to this quadratic equation are 11 and 1. Let's do another example where we do all the steps at one time. So in this case, we have x squared minus 18x minus 40 equals 0. The first thing we want to do is isolate the terms with x in them. So we're going to add 40 to both sides of the equation. So we end up with x squared minus 18x equals 40. And then the second step is to complete the square. So we're going to add half of negative 18 to both sides squared. So we're going to have x squared minus 18x plus negative 9 squared equals 40 plus negative 9 squared. And then we're going to continue and we're going to simplify the right-hand side. So we have 40 plus 81 is 121. And then on the left-hand side, we have a perfect square trinomial. So we have x minus 9 squared. And then after we've completed the square, we take the square root of both sides. We end up with x minus 9 equals plus or minus 11. And then we solve two equations. So we have x minus 9 equals positive 11, and x minus 9 equals negative 11. So in both cases, if we add 9 to both sides, we end up with x equals 20, and x equals negative 2. Let's do one more example of completing the square. Because the first two problems both ended up with integers as their solutions, and that's not always going to be the case. So in this case, we have x squared plus 6x minus 59 equals 0. So if we isolate the x terms, we have x squared plus 6x equals 59. And then what we want to do is complete the square by adding half of the b term, or half of 6 squared, to both sides. So we end up with x squared plus 6x plus 3 squared equals 59 plus 3 squared. And then on the right-hand side, we have 59 plus 9, or 68. And on the left-hand side, we have a perfect square trinomial, so we have x plus 3 squared. So we've completed the square. Now we take the square root of both sides. So we end up with x plus 3 equals plus or minus the square root of 68. And then we can solve this by subtracting 3 from both sides, and we end up with negative 3 plus or minus the square root of 68. And then the one thing that we always want to do if we end up with an answer that looks like this is we want to simplify any radicals that can be simplified. And the square root of 68 is equal to the square root of 4 times the square root of 17, which ends up equal to 2 times the square root of 17. So we can replace the square root of 68 with 2 times the square root of 17. So our solution ends up being negative 3 plus or minus 2 times the square root of 17. All right, let's do one more example. So with this one, we want to isolate the x terms. So we end up with x squared minus 16x equals 76. And then we want to add half of the b term squared to both sides. So we're going to be adding negative 8 squared to both sides. So we have x squared minus 16x plus negative 8 squared equals 76 plus negative 8 squared. So then on the right-hand side, we have 76 plus 64, so that's 140. And on the left-hand side, we end up with x minus 8 squared. So then we've completed the square, so we take the square root of both sides. So we end up with x minus 8 equals plus or minus the square root of 140. And then we can solve. So we're going to add 8 to both sides. So we have x equals 8 plus or minus the square root of 140. And then we can simplify the square root of 140 and rewrite it as the square root of 4 times the square root of 35. So we end up with 2 times the square root of 35. So x equals 8 plus or minus 2 times the square root of 35.